The inspector's requirement for an additional ground wire is not redundant grounding, it is a safety measure. The existing ground wire provides a path for fault current to return to the source, but its connection to the concession stand frame presents a potential issue. Because the concession stand is a temporary structure, moving or removing it would sever the ground connection. The additional ground wire from the ground bar to the ground rod establishes a permanent and reliable ground for the panel. This ensures a continuous path for fault current, even without the concession stand. Grounding systems are crucial for electrical safety, especially in temporary setups like concession stands. A proper grounding system protects against electrical shock and equipment damage. Let's break down the components and requirements for a safe and compliant temporary power grounding system. Firstly, the purpose of a grounding system is to provide a low impedance path for fault current to return to the source. This allows overcurrent protection devices, such as circuit breakers or fuses, to quickly clear the fault, minimizing the risk of electrical shock or fire. Secondly, the ground rod serves as the earth electrode, providing a direct connection to the earth. This helps to stabilize the electrical potential of the system and provide an additional path for fault current. Thirdly, the ground wire, also known as the equipment grounding conductor, connects non-current carrying metal parts of electrical equipment, such as the panel frame and the concession stand frame, to the grounding system. This ensures that these parts are at or near ground potential, reducing the risk of electrical shock. The connection at the manhole is important, but it is not sufficient on its own. The manhole connection provides a ground reference for the source of power, but it does not guarantee a reliable ground connection for the panel itself, especially considering the temporary nature of the setup. The inspector is likely concerned about the potential for the existing ground wire to become disconnected or damaged. If this happens, the panel and the concession stand frame could become energized, posing a significant safety hazard. The additional ground wire provides a redundant ground path, ensuring that the panel is always grounded, even if the existing ground wire fails. The requirement to remove the jumper to the rod and run a separate conductor from the ground bar ensures a direct path to ground. It prevents relying solely on the frame of the concession stand as part of the ground path. The 4-5 cord is likely sized appropriately for the 100 amp 3-phase panel, but it is essential to verify that the ground wire within the cord is also adequately sized according to the National Electrical Code, or NEC. Refer to NEC Table 250.122 to determine the minimum size of the equipment grounding conductor based on the size of the overcurrent protection device protecting the circuit, which in this case is 100 amps. The separated neutrals and grounds at the panel is a correct and safe practice. This prevents neutral current from flowing on the grounding conductors, which can cause nuisance stripping of ground fault circuit interrupters, or GFCIs, and increase the risk of electrical shock. The grounding electrode conductor, which connects the ground bar to the ground rod, must also be sized appropriately, in accordance with the NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors or the equivalent for a separately derived system. It's important to use the correct type of wire for grounding. Typically, green insulated copper wire is used for equipment grounding conductors, and bare copper wire is used for grounding electrode conductors. The connections to the ground rod should be made with listed grounding clamps or connectors. These connectors are designed to provide a secure and reliable connection that will not corrode over time. The ground rod should be driven into the earth to a depth of at least 8 feet, and it should be located as close as possible to the panel. If multiple ground rods are used, they should be spaced at least 6 feet apart. The inspector is likely following the guidelines outlined in Article 590 of the NEC, which covers temporary installations. Article 590 emphasizes the importance of providing a safe and reliable electrical system for temporary power setups, especially in areas accessible to the public. The fact that the concession stand will only be there for 17 days does not negate the need for proper grounding. Even though the installation is temporary, the risk of electrical shock and equipment damage is still present. The inspector is responsible for ensuring that the electrical installation meets the minimum safety requirements of the NEC. By requiring the additional ground wire, the inspector is taking a proactive approach to prevent potential hazard. Remember to use appropriate personal protective equipment, or PPE, when working with electrical systems. This includes gloves, safety glasses, and insulated tools. Always de-energize the circuit before working on any electrical equipment. Verify that the circuit is de-energized using a voltage tester. Follow lockout-tie-out procedures to prevent the circuit from being accidentally re-energized while you are working on it. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. An electrician has the training and experience to safely and properly install and maintain electrical equipment. Properly installed and maintained grounding systems are essential for electrical safety. Do not take shortcuts or cut corners when it comes to grounding. The safety of yourself and others depends on it. If the inspector requires additional measures, it is best to comply. The inspector is acting in the interest of safety and is ensuring that the electrical installation meets the minimum requirements of the NEC. Ensure that all electrical equipment used in the concession stand is listed by a recognized testing laboratory such as Underwriters Laboratories, or all. This indicates that the equipment has been tested and meets safety standards. Use ground fault circuit interrupters, or GFCIs, to protect circuits that serve receptacles in wet or damp locations, or where there is a high risk of electrical shock. GFCIs are designed to quickly detect and interrupt ground faults, preventing electrical shock. Regularly inspect the electrical system for any signs of damage or deterioration. This includes checking for loose connections, frayed wires, and cracked insulation. Repair any damage immediately. Be aware of the potential hazards associated with temporary power setups. These include overloaded circuits, damaged equipment, and improper grounding. Take steps to mitigate these hazards. Ensure that all employees working in the concession stand are trained on electrical safety procedures. This includes teaching them how to identify electrical hazards and how to respond in an emergency. Post electrical safety signs in prominent locations around the concession stand. These signs should warn people of potential electrical hazards and provide instructions on how to stay safe. Develop an emergency plan in case of an electrical incident. This plan should include procedures for shutting off the power, evacuating the area, and contacting emergency services. By following these guidelines, you can help to ensure a safe and compliant temporary power grounding system for the concession stand. Remember that electrical safety is everyone's responsibility. Report any electrical hazards to the appropriate authorities. Regularly review and update the electrical safety procedures. Keep up to date with the latest electrical codes and standards. The NEC is updated every 3 years, so it is important to stay current with the latest changes. Consider attending electrical safety training courses to enhance your knowledge and skills. There are many resources available to help you learn more about electrical safety. These include online courses, seminars, and workshops. By investing in electrical safety, you are investing in the safety of yourself, your employees, and the public. Consider the specific requirements of the local jurisdiction. Local electrical codes may have additional requirements beyond those outlined in the NEC. Consult with the local electrical inspector to ensure that the electrical installation meets all applicable requirements. Document all electrical work that is performed. This includes keeping records of inspections, repairs, and modifications. These records can be helpful in the event of an electrical incident. Consider using a qualified electrical contractor to perform electrical work. An electrical contractor has the expertise and experience to safely and properly install and maintain electrical systems. Get multiple bids from different electrical contractors before hiring one. This will help you to ensure that you are getting a fair price. Check the electrical contractor's license and insurance before hiring them. This will protect you in the event of an accident or injury. Ask the electrical contractor for references from previous clients. This will help you to assess the quality of their work. Review the electrical contractor's contract carefully before signing it. Make sure that you understand all of the terms and conditions. Do not hesitate to ask the electrical contractor questions if you have any concerns. A reputable electrical contractor will be happy to answer your questions and address your concerns. By following these tips, you can help to ensure that you are hiring a qualified and reputable electrical contractor. Remember that electrical safety is an ongoing process. It requires constant vigilance and attention to detail. By making electrical safety a priority, you can help to prevent electrical accidents and injuries. Proper grounding is not redundant, it is a critical safety measure. It protects lives and equipment. The inspector's requirement is based on sound electrical safety principles and should be followed. Ensuring a secure and reliable ground connection is a fundamental aspect of electrical safety, especially in temporary installations. The purpose of this additional grounding is to provide a robust safety net against potential electrical faults and hazards. This approach is in line with best practices for electrical safety, particularly in temporary setups.